Okay, so this is the review for exam 3.
It's okay.
Are we signing that?
Sorry, I wouldn't do recording.
So, let's start off with effective nuclear charge, or ZF. Let's try for a neutral atom and do just a regular old atom. Let's try magnesium. How about that? Magnesium. So if you want to find magnesium's Z effective, the formula for this is Z effective equals Z minus S. Z means the number of protons, and S is the core electrons. Okay? Now, the difficulty here is figuring out which ones are the core electrons. The core electrons are just every electron underneath the valence shell. Okay?
Yes.
So anything that's not a valence electron is a core electron, just by the definition. Right? So for magnesium right here, magnesium's number of protons. How many protons are in magnesium?
12.
12. How many core electrons do we have in magnesium?
10.
10. Okay. So the Z effective is
2.
2. So it's positive 2. That's right. Okay, that's the Z effective
Do
for
we
a
have
regular neutral magnesium atom.
Yes.
And in fact, every atom on the periodic table, if it is neutral, is just going to have the Z effective be the number of neutrons it normally has. No, I'm sorry, the number of valence electrons. Number of
If
valence
it's
electrons.
neutral.
If it's neutral. See,
Do you got to write a positive?
you don't have to. It's always going to be positive. Yes.
Are you going to give us ones with the transition metals?
I could.
Okay.
If I did,
What are the transition metals?
what are the
ones in
valence
the middle.
electrons for the transition metals that we've gone through so far?
2?
They're always going to be 2. Okay? So that they're easy, actually.
You can work it out, but like it's always going to be 2.
It's always going to be 2. Yeah, you can work it out. Okay, so that's a pretty simple, straightforward idea. And if you want to define what Z effective is, a more basic question, maybe a more difficult question would be, how would you define the effective nuclear charge in your own words? How would you do that?
The charge fell by the valence electron towards the nucleus
Nucleus,
of
yes.
the atom.
Perfect, that's perfect. Okay. The textbook definition. Charge fell by the valence electrons towards the nucleus. You put it in that position. Now we have, let's charge this magnesium. So that was regular magnesium, which is neutral. So now let's do something different. Let's say it's positively 2 charged, meaning that we take away 2 electrons. Okay? So
We take away, not
so
add.
you're taking away.
Okay.
It says plus 2, that means that there's an extra positive 2 charge. So that means you must have taken away 2 negatives.
Yes.
Oftentimes people get confused about this because they think, oh, plus 2, that means you add 2 protons.
Yeah.
But that can't be right, because if you add 2
Then
protons,
it's not magnesium.
it's a different element. Yeah, it's not magnesium anymore. It's silicon.
But aren't you adding 2 protons and just taking away the valence electron so it becomes unbalanced? Isn't that what that means?
What this means is that you're just taking away 2 electrons.
Okay, so nothing's happening to the protons.
The protons are staying put. We know that because it's still magnesium. Okay? Magnesium, if you change the protons, then it's not magnesium. It's something else. Okay?
So you never change the proton.
So you're never changing the
So
protons.
if it's magnesium minus 2, it means you took, no, you
You
added
put
2 electrons.
Exactly. So if it was magnesium minus 2, then you would have added 2 electrons, because electrons are negatively charged. So here we are. We got magnesium plus 2. Now, normally you'd write out its electron configuration like this. I'll write this out right now. 1s2. And by the way, you are going to need to know how to write out electron configurations for the test.
Are you serious?
It's something that you just need to keep on practicing. Okay?
Are you gonna give us the Seattle principle?
The Aufbau?
Yeah.
Would you like the Aufbau?
Yeah.
Okay. I'll put the Aufbau.
Then can you teach us like the shorthand?
Yeah, the
like
shorthand.
the tricks that
Please,
Michael and everyone
please
teach
teach
us.
You don't know?
No,
I
Oh, I don't know either. I don't know either.
Now, this is the normal electron configuration for magnesium, right here. Right? If I wanted to write the shorthand for the normal magnesium configuration, all you have to do is to go to the noble gas
Neon.
before
And then
magnesium, which would be,
Neon.
what's the noble gas before
Sodium.
magnesium?
No.
The noble gas.
Oh.
You're going in the right
You have
direction.
to find
Keep on
two.
going backwards.
The one in front. The one
The
before.
neon, yeah. So
So you
neon.
have this one is this one. If you have that one is this one.
And if you look at what neon's electron configuration is,
This be this? No, no. It has to be a noble one. Okay.
well, I'm going to do this in a different color. Neon's electron configuration is just this. It is this right here.
That's neons.
That's neon. Oh, I'm sorry. I should have put the 6 in there. I cut that off on accident. Okay. That is neon.
But we're looking for magnesium.
Right. So if you want to write out fully, if you want to write out magnesium's electron configuration, now you've got to add this extra 3s2. So that is magnesium written with the noble gas shorthand method. Yeah.
But how do you know whether to put, like, let's say we wanted to skip doing the what do you call the first one we did, the first way?
This is just a long...
The long way of doing it. What if we wanted to have, because people, I've seen people like Mike and just be like, oh, that's the no, how do they do that? They can't actually, they didn't do the long way out in their head, did they?
No, they didn't.
So
That'd
what
be
was,
pretty quick, wouldn't it?
yeah.
All they did is they looked... So if you look at where magnesium is on the periodic table, it looks like this. Here's a periodic table, right? Magnesium's right over, right here.
Yes.
Right? So when I always say, look at the noble gas in front of that element.
So that's going to be neon.
So yeah, so when I say in front, I mean go before whatever element you have, and whatever noble gas is in front of it. So in this case, it's neon. Neon's
Got
right
that.
here.
Yeah, got it.
Okay? And these are all the noble gases on the right-hand side of the periodic table. So all you have to do is write in parentheses neon, and then you just add the extra electrons, which would just be the valence electrons anyway.
What do you mean?
They would just be the valence electrons. These are the outer shell.
How do you know that, though? without
Because
doing the
neon's
math?
got a full shell.
Neon's got 8.
Neon's got, look at all its valence electrons. It has all of these, those are full valence electrons right there. You've got 2 and 6, that's 8 altogether. So it's got a full valence shell.
What about the other two that you forgot to circle?
This?
No, the other one. The 1s.
Well, that's a one.
Oh, that's underneath it. So
Okay.
you can think of neon as having a complete inner shell. Here's neon with its nucleus in the middle. And its outer shell has 1, 2, 3, 4, 5, 6, 7, 8. So it's completely filled. It's got a full valence shell. This is neon. Right? Now, if you want to change this, you just add a couple more protons, 2 more protons in the middle, and 2 more protons on the outside, and now it's magnesium. Okay? So when you're writing this electron configuration out, when you're writing this out, all you need to do is write out, oh, neon plus a couple more electrons.
But how do you know it's 3s? I'm
You
sorry,
know
I'm
it's
just,
three
I
S.
just,
It's
Half bow.
It's
I'm
alright.
just really confused.
You can know the Aufbau principle by looking at where the arrows go. If that doesn't help you, you can also look and count down 1, 2, 3 rows, right?
Okay.
And 2 over. We've got 1, 2 over. So if this is the S's, this is the P's, these are the D's. If you count 2 boxes over, that means these 2, there's going to be 2 electrons in the S orbital.
Yes, because it's 2 valence electrons.
Right.
Okay,
Where
so
does the D stop and where does the P?
Stop right
right at CM.
there.
Right here.
And then the F's are down below.
Okay, so you can basically just go count it down 3 and then go over 2, and then you know that's 3s too. And what? Okay, that's S.
And
Okay.
you could just say, or the noble gas in front of that is neon.
And then you add the neon before it.
And that'll get you the noble gas
Okay,
configuration.
got
So
it.
it's really quick, it's really easy, it'll save you time on the test.
Yes.
Are P's a part of the noble gas? Like, are noble gas part of the P section?
Our noble gas is a part of the P section.
Yeah.
Yes, you
Yeah.
consider them a part of the P section. The only thing that the only exception here is this. This is an S.
Oh,
It is helium. Helium and hydrogen, they have the first shell.
They're not, helium is not a noble gas.
Helium is a noble gas, but it's,
Hydrogen is the one that's
but it's
not.
in the S orbital. Right? It doesn't have a P.
Oh,
so
the first one is 1 is 2. There's no 1
That's right. There's no 1P.
Okay.
Okay. It's just 1s2.
I don't know.
Full shell. Okay. So that's it. That's a nice little review of electron configurations. So we've got that. We've got this right here. But now I'm going to change it because this was the regular neutral magnesium, but now we're going to have this magnesium be charged. It's going to be +2 charge. So in order for it to be +2 charge, you got to take away 2 electrons. We're always going to take it away from the valence shell. So let's take away 2 electrons from this. All right. Well, let me do that. Oh my God.
You take the whole thing away.
Oh my God. So this changes. Oh my God. So now we've got, instead of that being the core, now this is the valence. We got this is the core, now this is the valence. Okay? So it takes on this neon arrangement of electrons. It's got a full valence shell. Okay? But it still has all of its protons that it normally had. This is where it gets a little bit confusing because you're not really sure what the charge is going to be on these electrons right here. So you use this formula, which is ZF equals Z minus S. It won't lead you astray. So we've got the protons right here. How many protons in magnesium? 12. So we do 12. You minus the core electrons. The core electrons are no longer these electrons and these electrons put together because we've taken off. It formerly was this, but now since we've taken these 2 electrons away, now we've got the core as being
2.
There's 2 of them, right? So now it's 12 minus 2, and this will equal
8.
10.
That's right,
10. Very good.
So just in general, if we wanted to just do it quickly, like if we take off, we just know that the core is going to be the first one I don't know what you would call it, the first one you did right there.
Yeah, you know that this is the core because it has a 1, and these both have a 2 for the shell.
So it's always going to be thin one.